We're going to take a look at converting from standard notation to scientific notation. So again, scientific notation is used to describe either very large or very small numbers in a compact way. So when we're describing scientific numbers with scientific notation, numbers that are less than one, so what you might think of as decimals, right, use negative exponents. So that is, we use the exponents to express how we are moving our decimal point, right? How many decimal places we are moving it. So our goal is to always end up with a single value to the left of the decimal, a single non-zero value. So if I'm looking at this number, I would like my decimal point to end up right in between the 2 and the 3. So I'd like this to be 2.3 times 10 to the, and now we have to move the decimal point. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. And because this is a small number, we're going to express it as a negative. So the exponent always tells us how to undo what we just did to the number. So the exponent, a negative 12, if you think about a number line, negative values are to the left of 0. So a negative, if we were to put this new scientific number, notation number, into standard form, that negative tells us to move the decimal point to the left. Okay, so when we're working with these very small numbers, we're always going to have that negative exponent. Okay. So something else we can do is take numbers that are almost in scientific notation, but not quite, and we can put them into scientific notation. So if I look at this number is not currently in scientific notation, and that's because the first number is not greater than or equal to 1 or less than 10, right? That's that restriction on the first number. So we need to put this into scientific notation. So one thing about scientific notation is the movement of the decimal point and then what we do to the exponent. Again, they work in opposites. So if I move this exponent to, or this decimal to where it needs to be, right behind the 4, that's 1, 2, 3, 4 spaces to the right. My exponent needs to tell me how to undo that. So right is normally a positive direction. So to undo a plus 4, we would have to subtract 4. So that's what I'm going to do to my exponent. I'm going to subtract 4 from my exponent. So this becomes 4 times 10 to the negative 8. Another way to do this is alternatively to take your value and to put it into standard notation. So if we had this and we were putting it into standard notation, oops, this should be a 4, we would move this decimal place 1, 2, 3, 4 to the right. And then we could then from scratch put it into scientific. So we'd want to move it 1, 2, 3, 4, 5, 6, 7, 8 to the right. And we'd still end up with 4 times 10 to the negative 8. So whichever way you're more comfortable, put it in standard notation, then move it fully into scientific, or work with it in the sort of scientific format. So numbers that are very small use negative exponents, but numbers that are very large are expressed using positive exponents. So if we were to express this number as times 10 to the scientific notation, we want that decimal in a similar place, right? We want it so that there is one non-zero value to the left of the decimal point. So we want this to be 4.5 times 10 to the, we want to see how to move that decimal. So we're going to move that decimal from where it is, 1, 2, 3, 4, 5, 6, 7, 8 to the left. The exponent says how to undo, so that's a positive 8. So again, those very large values are going to have positive exponents, meaning that the end result when we take it out of scientific notation is a very large number. So again, we can put things into scientific notation that are only approximately in scientific notation, or in what looks like scientific notation, but actually isn't. So if this was in scientific notation, the decimal would need to be in between the 4 and the 8. It's currently not. So same issue, first number is not greater than or equal to 1 or less than 10. Excuse me, and less than 10. So we do need to put it into scientific notation. The decimal is currently behind the 5. We need to move it to the left 2. So that's in the leftward direction 2. So we can think of that as a -2. The exponent always undoes the movement of the decimal. So instead we would add 2 to that exponent, and we'd end up with 4.85 times 10 to the 8th. So let's go ahead and put a couple of numbers in scientific notation here. All right. So first value, you can always place your decimal even if it doesn't have one. So we want to end up with our decimal right in between the 3 and the 4. So we wanted to say 3.4 times 10 to the, and we have to determine what that exponent is. So let's move our decimal, 1, 2, 3, 4, 5, 6. All right, and this is a number, a large number, so it's going to be positive, right? We moved it to the left, which means the exponent needs to say how to undo that, so positive 6. Okay, so this guy, we want that decimal in between the 2 and the 5, so this will be 2.5 times 10 to the, and we need to decide how many. So 1, 2, 3, 4, 5, 6, 7. So we moved it 7 to the right. It's a small number, so that means our decimal is going to be -7 there. So the exponent always does the opposite of what you think on the number line. So if we move the decimal to the right, 7, then the exponent needs to undo that, moving it to the left or subtracting 7, right? You always want to work in opposites. Okay, so let's do this one. Decimal goes in between that 4 and the 5, 4.56. So you just want to remember, we only ever want one value, one non-zero number to the left of that decimal point, right? Something only in that ones place. So times 10 to the, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So times 10 to the 11th. Okay. Last one here before we get into converting from almost but not quite scientific. So we want the decimal to be right after the 6. This is going to be 6 times 10 to the 1, 2, 3, 4, 5, 6. That went to the right, so that means that our exponent needs to be a -7 there. All right, so let's convert these guys. So this is almost in scientific notation, but not quite. Our decimal needs to be 2 more to the left here. So left is typically subtraction. Decimal and exponent move in opposites. So if the decimal moved to the left 2, the exponent, we need to think about going to the right 2 or undoing that movement, and right is typically positive. So we'd have 3.56 times 10 to the -6. So -8 plus 2 is -6. Next one, our decimal should be in between the 6 and the 7. So we're going to move it to the right 1. Right is typically positive. The exponent needs to do the opposite. So we would need to subtract 1. So we'd end up with 6.7 times 10 to the 6th. So that's converting from standard notation and almost scientific to full scientific notation.